The objectives for this topic are calculate a line's slope, write the point slope form of the equation of a line, write and graph the slope intercept form of the equation of a line, graph horizontal or vertical lines, recognize and use the general form of a line's equation, use intercepts to graph the general form of a line's equation, and model data with linear functions and make predictions. Graphing linear equations. Those are equations that graph as a line, remember, right in the word, linear. And we're going to start off by looking at this form of a line. AX plus BY equals C. And this is called the standard form of a line. But you may hear me just call it AX plus BY equals C form. Here, X and Y are our two variables, and A, B, and C are any number. Let's show by point plotting that anything of this form is in fact a line. Let's first look at an example where A and B are both real numbers, as is C. So let's look at the line 2x plus 3y equals 6. Let's remember what we did with this in the prior lesson where we looked at point-by-point plotting. And let's develop a general strategy. So there are two ways we looked at to graph something like this. The first involved the intercepts. And remember, intercepts were the points where X is 0 and where Y is 0. And for a line, that gives us 2 points. The one where X is 0 means that we don't move left or right any on the x-axis. We do move up or down along the y-axis, and whatever point that's going to be, it's going to cross the y-axis. It is the y-intercept. How do we find it? We plug 0 in for x and solve for y. Remember, I said we can call this the cover-up method, because when we plug 0 in, it's like that term goes away, and we would just be left with 3y equals 6. 2 times 0 is 0. 0 plus 3y is just 3y. We divide both sides by 3, and we get y equals 2. So when x is 0, y is 2. We can go ahead and find the other intercept where y is 0, so we don't move up or down at all. We're just moving left or right along the x-axis. It'll be an x-intercept. And to find that, we plug 0 in for y. Plugging in 0 is like making this term disappear. Covering that up, we see 2x equals 6. 3 times 0 is 0. 2x plus 0 is just 2x. Continuing to solve, divide both sides by 2. We get x equals 3. This gives us 2 points that we can plot. The first row gives us the ordered pair 0, 2. The second row gives us the ordered pair 3, 0. If we graph, plot our 2 points, 3, 0, that's an x of 3. 0, 2, that's a y of 2. And then we use our straight edge to draw the line right between these 2 points. So that's one method we have of graphing something in this form. When we have real numbers for A, B, and C, in this case, remember we had 2x plus 3y equals 6. We can use the intercepts to get a point on the y-axis, get a point on the x-axis, and draw the line through. Now I'm going to show the other way, because I had said I'm going to go through and I'm going to show you, I'm going to prove to you that it is actually a line. And while you only need 2 points for a line, who's to say that it actually did that? Without some more points, how am I going to convince you that that is how we connect these? And it's not something weird like this. That goes through these 2 points as well. So again, 2x plus 3y equals 6. Instead of using the intercepts, we can just make a regular old XY table that's not limited to just 0 for the X and 0 for the Y. And in order to do this, we should solve for one of these variables. And you're going to see throughout the course of this lecture, it's actually going to be useful for other forms if we get used to solving for the Y. So we're not plugging 0 in for X or anything like that yet. Like we did last time, we're just going to solve this equation for Y in terms of X. So when we're done, we'll have Y equals something involving the X. So it's just like solving a regular equation. We want to get the Y by itself. So we want to get the 3y by itself. So we want to subtract the 2x. This gives us 3y equals 6 minus 2x. Then dividing both sides by 3. Well, before we do this, let's get in the habit of doing something else. When we have something written like this with the x term second, let's go ahead and use our properties of addition, where we can add terms in any order. And let's go ahead and put the x term first. So 3y equals, this will be negative 2x plus 6. Remember, we can't just switch it around the minus side. 6 minus 2x is the same as 6 plus negative 2x. We can switch them around, the addition sign, negative 2x plus 6. Okay, in our next step, we'll go ahead and finish solving for y by dividing both sides by 3. When we do this, I'm going to go ahead and erase the xy table for now, just to give myself a little more room. When we divide both sides by 3, that's just going to leave us with the y on the left, and on the right, both of the terms, the negative 2x and the 6 both of those terms will get divided by 3. Simplify them both individually. Dividing this by 3, we can do the negative 2 divided by 3 to get negative 2/3. And that x is actually just going to go ahead and float right next to the 2/3. 6/3, that's 2. So this is plus 2. You might be asking, why does this just float off the end there? Well, I want you to consider this. Why is the negative out front as well? That could be a question you have. Negative 2x over 3 could be considered the same thing as negative 1 times 2 times x over 1 times 3 times 1. 1 times 3 times 1 is 3. Negative 1 times 2 is negative 2 times x is negative 2x. That would be the same as negative 1 over 1 times 2 over 3 times x over 1. Negative 1 over 1 is negative 1 times 2/3. X over 1, that's just x. Negative 1 times something is just like making it negative. So negative 2/3 x. We don't have to do all this work every time, because this is what's happening in the background. Whenever we see something like that, negative 2x over 3, we can just go ahead and make it a negative fraction with the x floating next to the fraction, because x over 1 is just x. Okay, why did we solve this for y? Well, we could have just started picking x's and plugging them in. But when it's like this, we see that to find our y, we're going to need to take our x and divide it by 3. So we want our x to be a multiple of 3 so that we can easily find these y's. Solving it for y first helps us know that when we do start picking our x's that we're going to then solve and find our y's, we would like them to be multiples of 3. So things like negative 6, negative 3, 0, 3, and 6. How do we find y values when we have x values? We plug them in, like the old Glade commercial. So we have y equals negative 2/3 x plus 2. What about when x is -6? Well, -2/3 times -6. Negative times negative is positive. 2 times 6 is 12. Divided by 3, that's going to be 4. Plus 2 gives us a y of +6. If you want to see more steps here, I'll go ahead and show this again. -2 times -6 would be +12 divided by 3. 12 divided by 3 is 4. 4 plus 2 gives us our 6. Let's go again. What about when we plug in -3? -2 times -3 would be +6. +6 divided by 3 is +2. 2 plus 2 gives us 4. Plugging in 0. Well, anything times 0 is 0. Plus 2 gives us 2. Plugging in 3. -2 times +3 is -6. -6 divided by 3 is -2. -2 plus 2 is 0. And I have one more value. I'm going to go ahead and get one more x value that I'm going to go ahead and get a y value for. When I plug in x is 6, -2 times 6 is -12. -12 divided by 3 is -4. -4 plus 2 is -2. What do we do with our XY table? We plot these points. My x's need to go from -6 to +6 at least. My y's, I'm going to need -2 up to 6. 1, 2, 3, 4, 5, 6. -6, 6. -3, 4. 0, 2. 3, 0. 6, -2. Now, you'll notice that my drawing strikes again. These points don't exactly line up, but it's not because they don't fall on the same line. If you were using graph paper, you would see these perfectly fall in a line. The issue is that my marks are not evenly spaced. 6 here is not actually exactly the same as 6 here, and is definitely not the same as 6 there. So that's why there's a little bit of disparity here. But again, if you're using graph paper, these are going to be right in a line. It's funny. I did this to show you absolute proof they were on a line, and then goes to show human error of drawing lines. In fact, I'm not going to be able to let this go. Let's go ahead and show that it does make a difference here. I'm going to go ahead and use my ruler. Okay. Let's try this again. So this is 2x plus 3y equals 6 using these points on an actual scaled graph. So again, negative 6, 6. That's going to be here. Negative 3, 1, 2, 3, 4. That's going to be there. 0, 2. 3, 0. 6. Negative 2. Look at that. Actually hitting all the dots. So it is a line. And any point I pick and plug in that satisfies this equation, any x and y that makes this true is somewhere on this line. That's why it is a linear equation. Its points come up in a line. Okay, so A, B, and C can be any real number, but what happens if they are 0? Well, the situation where our A is 0 and where our B is 0 is going to cause something similar to checking for intercepts. If our A was 0, then this goes away. There is no X left. We would have something in the form BY equals C. Let's say we had 2y equals 4 and we wanted to graph this. Well, we can plot points. Let's solve it for y, and we can see this actually simplifies to the equation y equals 2. But there's no x here. So if we were to make an XY table and plug values in, there's actually nothing to plug our x's into. So when x is negative 2, guess what?
y equals 2. Well, what about when x is -1? Well, y equals 2. Okay, well, what about when x equals 0? Y equals 2. Okay, but what about when x is 1? Y equals 2. Well, what about when x is 2? Y equals 2. Well, I wonder what this looks like. Here we're graphing 2y equals 4, which is essentially y equals 2. So if I'm graphing -2, 2, -1, 2, 0, 2, 1, 2, 2, 2, it is a line. It's a horizontal line. It's a horizontal line that goes through a single y value. Y equals 2. So y equals a number that's a horizontal line. Yes, we are about to go through the same skit with the x equation. Okay, so what about when the b is 0? That's going to make there be no y term. So something in the form ax equals c, that is also going to be a linear equation. If the other one, if y equals a number, gave us a horizontal line, we might even think, maybe x equals a number gives us a vertical line. Let's see how that pans out. Let's graph x equals -3 and see if it's a line and what kind of a line it is. Well, if we had an XY table, it's going to be the same situation, except this time, if we were going to try to plug some Y values in, we have no place to put them. But what we do have is this rule that X equals -3. It says nothing about Y. X equals -3 is this problem's Y equals 2. So when Y is -2, X equals -3. When Y is -1, X is -3. When Y is 0, X is -3. X is -3, X is -3. Let's graph these points. I have a feeling X equals -3 is going to be important. And they most certainly do fall on a line. A vertical line, just like we thought might happen. And where does that vertical line exist? X equals -3. So one way I like to keep straight which one's horizontal and which one X equals a number is vertical is that I like to remember that x equals -3 passes through the x axis. Y equals 2 pass through the y axis. So if I see x equals a number and I'm asked, is that a horizontal or a vertical line? All I have to do is think x equals a number, passes through the x axis, which means it is a vertical line. We'll do some more with horizontal and vertical lines in the future. But for now, I would like to point out that we can have 4 types of lines based on what we've seen. Horizontal, vertical, and my camera apparently is a little bit tilted, so let me see if I can make this horizontal line anymore. There we go, horizontal, flat. But we could also have diagonal lines, and diagonal lines can either go bottom to top, from left to right, or from left to right, they can go top to bottom. They can go up, they can go down. We read lines like we do English language words, left to right. Okay, if you're watching my hands, left to right. If you're watching my whole body, left to right. Okay, that was weird. Left to right. There we go. Follow the arrow. It's the 2 camera thing. The one facing me. Okay. It's important that we have these 4 different types of lines, and we describe each of these in terms of their slant, in terms of their slope. Something that rises from left to right, we say has a positive slope. Something that falls from left to right, we say has a negative slope. Something that is flat, you can imagine driving a car and it not being uphill or downhill, just being flat. We say that has 0 slope. And if something is straight up and down, maximum steepness, we say that that slope is undefined. And now we're going to talk about what slope is numerically and how to find it. And by the time we're done with that, each of these 4 names is going to make complete sense as to why we call this a positive slope, this a negative slope, this 0, and that undefined. Okay. Slope is considered rise over run. You may have heard rise over run before in relation to slope. But what does that mean? Well, rise is how much you go up or down. Run is how much you go left or right. Well, wait a minute. When we're graphing up and down, that's our y. That's our y-axis. And how much we go up or down from where we start to where we finish could be considered the change in y. And this Greek letter delta, this triangle, mathematically means change in. So how much we go up or down from one point to another, that would be our change in y. How much we go left or right, that's our x. So from one point to another, how much we go left or right would be the change in x. So if we have two y values and we want to find the change in them, the difference in them, we can take y2 minus y1, where our 2 points, our two xy coordinates, our ordered pairs, are x1, y1, and x2, y2. To find the change in y, we would go y2 minus y1, and we would go x2 minus x1. And it doesn't really matter if we do one or the other. It's just it's important that whichever one we pick first, we do first for the y's and the x's. So you can do y1 minus y2, but if you did that, the bottom would have to be x1 minus x2. So either y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. And you're going to see the 2 minus 1 more often. But again, order doesn't matter as long as you keep them straight. And that's because who's to say that what I pick as my second point and as my first point aren't what you pick as your first and second? So the order is not going to matter as long as we're consistent. So this is what we call the slope formula. y2 minus y1 over x2 minus x1. And slope in math generally uses the letter m. So when we see m, that's going to mean slope. So let's find the slope of some lines that pass through some particular points using our slope formula. Let's start with the points -3, -2, and 2, 5. So if we call this x1, y1, and x2, y2, be careful. Don't get tripped up and go x1, x2, y1, y2. This isn't a point x and a point y. These are two coordinates. Coordinates have the form xy. So the first is always an x, the second is always a y. So y2 minus y1, 5 minus -2. x2 minus x1 to minus -3. It's important that we keep minus the negative because that's how we know that this is 5 plus 2 over 2 plus 3. This is positive 7 over positive 5. And we can't reduce that or simplify that any. So the slope of the line is 7/5. Now, what does that actually mean? That means that 7/5 is the rise over the run of this line. If we have a point, then to get another point, we would have to rise 1, 2, 3, 4, 5, 6, 7. And we would have to run 5. 1, 2, 3, 4, 5. And I probably should have done that from up here because a rise and then going back to the starting point, a run doesn't there we go. Doesn't do us much good. There we go. So if we went up 7 and right 5, we would get another point on the line. This is what a slope literally means. Points on the line are separated by a rise of 7 and a run of 5. Rise over run. Notice this is a positive 7/9. And what does our line look like? It rises from left to right. A positive slope. So a negative slope, one that falls from left to right, maybe it stands to reason that it's called a negative slope because we're going to get a negative m. Well, let's find out. Let's look at the points. -5/2, 0. And 1, -7. Well, since the formula is not getting any harder, the only way I can make this more challenging is to throw in things like fractions. But we do it the same way. Here's an x1, y1, our x2, y2. We're going to do y2 minus y1 over x2 minus x1. By the way, to help you keep straight that x's are on the bottom and not on the top, think of this as a picnic table. When you have x's on the bottom of the fraction bar, you have a nice solid foundation, 4 legs, what you'd expect to see for a picnic table. A picnic table can't be held up by y's, it would topple over. So you want your x's on the bottom. y2 is -7 minus y1 is 0 over x2 is 1 minus x1, -5/2. -7 minus 0 is -7. 1 minus a negative is 1 plus 5/2. Let's go ahead and add these. 1 over 1, but we need to have a denominator of 2. So 1 is 2 over 2 plus 5 over 2. And we have that -7 on top. Call this a complex fraction, fractions with other fractions inside of it. Two plus 5 is 7. So this is -7 on the top and 7/2 on the bottom. -7 over 7/2 means -7 divided by 7/2. Dividing by a fraction is multiplying by the reciprocal. -14 divided by 7 is -2. Negative times positive gives us that negative. So all of that math just works out to -2. And if we plotted these points, and since I'm using the ruler for tick marks, you know there must be something important about the graph I'm going to draw. If we plotted -5/2, which by the way is -2.5, so an x of -2.5 and a y of 0 would be right there. An x of 1 and a y of -7 would be there. So this line looks like that. Negative slope falls from left to right. And actually, it falls a slope of -2. That's -2 over 1. So that negative can either go with the top, -2 over +1, or it can go with the bottom, +2 over -1. So this is either down to right 1, or it is up to left 1. The motions are the same either way, reflecting that the negative can either be with the top or the bottom of a fraction if we have a negative overall fraction. So from here, down to right 1 gets us back to the line. Down to right 1, down to right 1, or up to left 1, up to left 1, down And right is the same as up and left. So negative numbers, negative slope, those fall from left to right. Positive numbers, positive slopes, those rise from left to right. What about those other two types of slopes, the zero slope and the undefined slope? Well, those appear to come from horizontal and vertical lines. Here's 2 points. And these 2 points do make up a vertical line, a line that we called undefined slope. And here are 2 lines. Or 2 points. Here are 2 points which make up a horizontal line. The 2 points for the horizontal line, -1, -2, and +4, -2. The 2 points for the vertical line, 2, 1, and 2, -3. So a horizontal line we can see has the same y coordinate. They're both -2. But that shouldn't surprise us because a horizontal line strikes the y-axis and is therefore the y equals a number. In this case, that line must be y equals -2. The vertical line has the same x value, but that shouldn't surprise us because a vertical line strikes the x-axis and is therefore the x equals a number special line. X equals 2. And remember, we said the horizontal line was called a zero slope. The vertical line was called an undefined slope. I want to write the whole word out. Undefined. Remember, I also said that by the time we're done talking about slope here, all 4 of the names would make sense. Positive made sense. Negative makes sense. Has to do with whether our answer for slope was a positive number or a negative number. So what do we expect the slope formula to work out to get something called a zero slope? we would expect it to be 0. Let's go through the motions. M equals y's on top. Y2 minus y1 would be -2 minus -2, which is a 0 on top. Any fraction with 0 on top, it doesn't matter. 4 minus -1 is 4 plus 1 is 5. It doesn't matter what non-zero number is on the bottom, because we can't have 0 on the bottom of a fraction. We get an answer of 0. So a horizontal line has 0 slope, because when we do the slope formula, since the y's are the same, that means we're subtracting something from itself on top, and we get 0. If we do it on the vertical line, y2 minus y1, -3 minus 1. On the bottom, x2 minus x1, 2 minus 2. That's 0 on the bottom of a fraction, and it doesn't matter what's on top. We can't have 0 on the bottom of the fraction because it's undefined. And that's why we call straight up and down an undefined slope. So to review the different types of slope we can encounter, a positive slope rises from left to right. A negative slope falls from left to right. Straight up and down, that's called an undefined slope. Flat, why, that's a 0 slope. And if you put it all together, you get slope guy. Now you get the slope guy Funko Pop. Okay. So what can we do with slope? Well, I've already shown you that it's a great tool to have to talk about the graphical relationship between one point and another. It's so useful that it actually has its own form of a line. So far we've talked about AX plus BY equals C form. That wasn't so bad. But if we solve it for Y, remember, we did that with real numbers in there earlier. We got this form that's Y equals, has an X term and has a constant term. This same this same form, we actually give different letters to. Y equals mx plus b. And for this b, we use a lowercase, not a capital. The b in ax plus by equals c. That's a capital B. Here we use a lowercase b. So slope-intercept form is solved for y, has an x term, and has a constant term. The number that is multiplied by x, the coefficient of x, when everything on the other side is just solved for y, m, no surprise here, that's the slope. M is our slope letter. The constant term, the b, that's actually going to be the y-intercept. Y. W-H-Y. Why? Well, what does it mean to be a y-intercept? It's the point where x is 0. If we plug 0 in for x, that goes away and we're just left with y equals b. So b is the y-intercept. It is the y value of the y-intercept. So why is this useful? Well, let's say we have something solved for y. Y equals 2/3 x minus 5. This is in slope-intercept form. It's in y equals mx plus b form. It's solved for y. It has an x term. It has a constant term. We can directly pull from here that the slope is positive 2/3 because that's what's multiplied by x. And that negative 5 is the y-intercept. In other words, 0, -5 is a point on the line. And with those two pieces of information, we don't need anything else to graph. How can we graph using slope-intercept form, finding the slope and y-intercept? Well, first, we take the y-intercept point and we plot it. So 0, -5, that's on the graph. A slope of 2/3, that's either +2 over +3, but it could also be -2 over -3. Negative over negative, that's positive as well. So positive would be up and right. So this is up to right 3, but it could also be down to left 3, negative in the y direction, negative in the x direction. So whatever's easiest to draw from here is what we're going to do. We're kind of out of room down, so let's look up and right. Up to right 3. And then up to right 3. And notice from any one of these points, we can go up to right 3, or we can go down to left 3, down to left 3, down to left 3. But really, once we have that second point, we don't need any more than 2 to draw our line. So with just slope-intercept form, we can graph the line, plot the y-intercept, draw the slope off from there. Some special situations, not so much special that they're different, but special some things we might not see. If we had y equals x plus 4, keep in mind we have that invisible 1 in front of the x. So the slope would be 1, the y-intercept would be 4. How about this one? Y equals 2x. Well, I said to be in slope-intercept form has to be solved for y. There has to be an x term, and there has to be a constant term. I don't see a constant term. That doesn't mean it doesn't exist. Plus 0 simplifies to 2x. And here we can see slope of positive 2, y-intercept 0. So here, the point 0, 0 would be on the graph. And we would go positive over positive. We would go up to right 1, or negative 2 over negative 1, down to left 1 to get this line. What about y equals 6? Solve for y. There's the constant term. Where's the x term? I don't see it. That must mean that there's 0 x's. M equals 0. B equals 6. Means 0, 6 is on the graph. Now, x equals 2, that's a line, but it can't be put in slope-intercept form. That's fine. The slope's undefined anyway. We wouldn't have a numerical value. Can't solve something for y if there's no y in there. So that x equals the vertical line. That is the only type of line that cannot be expressed in slope-intercept form. Okay, here we have 3x plus 4y equals 4. I'm going to go ahead and put this in slope-intercept form. Then I'm going to determine the slope and the y-intercept, and then I'm going to graph it. This would not be a good candidate for intercept form if you wanted to plot whole number intercepts. but you could do it. And just to show you that real quick, if I did do just plain old ax plus by equals c graphing, I can plot the intercepts, plug 0 in for x, 4y equals 4, so y is 1. Plug 0 in for y, 3x equals 4, so x is 4/3. We can go 0, 1. We can go 4/3, 0, so 1 1/3. And then draw that line through the 2 points. If it just said graph, you can do it that way. But very specifically, here, we are told, put in the slope-intercept form. That means solve it for y. Find the slope and the y-intercept, and then graph using this information. So even if you put the perfectly graphed graph as the answer, if you didn't plot the points that you get from doing it this way, it will be wrong. You have to do it the way it asks you to. So, solving. I'm going to go ahead and subtract 3x from both sides. We know 4 minus 3x is the same as negative 3x plus 4. I'm going to divide both sides by 4. Y equals, and we know this would be dividing both of these by 4. And simplifying that gives us negative 3/4 x plus 4/4 is 1. So that is a slope m of negative 3/4. The y-intercept b is positive 1. Let's graph. A slope of negative 3/4 is either negative 3 over positive 4 or positive 3 over negative 4. So when it comes time to do the slopes, that's down 3, right 4, or up 3, left 4. Where are we going to count from? That's what our y-intercept is for. A y-intercept of 1 means the point 0, 1 is on there. So from there, we either count down 3, 1, 2, 3, right 4, 1, 2, 3, 4. Or we can count up 3, 1, 2, 3, right 4, 1, 2, 3, 4. Either way, they're going to be right there on that line for us. And that's how we take something in ax plus by equals c form and graph it using slope-intercept form.